Hi, welcome back to LeetCode. So in this video, we discuss the second problem from our today's weekly contest of LeetCode. The second problem is that maximum number of subsequences after one inserting. So the problem statement is that you are given a string S consisting of uppercase English letters. Okay, so that means capital A to capital Z. So you are allowed to insert in at most one uppercase English letter at any position, including the beginning or end of the string. So that means suppose we actually have string X, Y, Z, all the characters will uppercase in capital. So, or actually I can actually insert a new character here between X and Y and between Y and Z and after Z. Got it? So there are four positions actually I can actually insert one character, but at most one character. That means this is optional. I can add one character or I will not add any character. Correct? So what I have to do? I have to return the maximum number of LCT subsequences that can be formed in the resulting string after at most one insertion. That means suppose actually I have insert one character, suppose A. Okay, so our resulting string will be A, X, Y, Z. Now what I have to do in this resulting string, I have to count that how many subsequences that is present in this resulting string, which actually is LCT. The subsequent string will be LCT. Got it? So we have to maximize this, right? The number of LCT, the subsequent string LCT, maximize the number of appearances in the resulting string. So to return the maximum number of. So that means, suppose for this example, LMCT. So if I do not want to add any new character, so by default, how many LCT is present? LCT, how many LCT is present? One is this LCT. So only one, correct? Now, what they are saying that I can actually add one character, any one character between A to Z and in any position. That means here, and here, correct? So there actually how many position actually I can actually add 1, 2, 3, 4, 5. 5 position. So brute force approach will be what? What actually I can think to solve this in brute force way? That actually our character space actually is between A to Z. So first of all, in this position, first of all I will add A. Then our resulting string will ALMCT. Then actually I will check that count LCT in this string. Okay. Then actually I will do what? LMCT. So then actually again I will count that how many LCT present in this string. Then actually I will do CLMCT. Correct. Again count how many LCT is present. Suppose here actually I got C1. Here actually I got C2 number of LCT. Here actually C3. So in this I will get in all positions I will explore. Suppose first I will explore Z LMCT. Okay. Suppose I here actually got C26 because there are 26 actually options are present, 26 characters A to Z. Then what I will do? I will actually add the character between L and M. So that will be LAMCT. Then again I will got C27. Got it? Again here actually I will change from A to B, LBMCT. So here actually I count that how many actually LCD is present. So this will be, suppose I got 28 number. Okay. So in this actually the what actually approach here actually, suppose actually the string is ABC. So what actually I am doing? So first of all, in each space, like or actually position, so I can actually add new character. So that actually I will explore that I will actually change like I will actually change each character from place one character from A to Z. So there are 26 characters present. Then actually I will count that how many LCT is present. Okay, so if there is suppose n number of positions actually present, so the time constant will be n into 26 because each position I can actually 26 I can actually add 26 characters, and for each character I have to count that how many LCT is present, the subsequent LCT is present. So it will actually check, it will take actually n into 26 into count, right? So count means here actually how can actually count? So count means suppose we actually have, so okay, so before that let's see how actually you are getting the output 2. So that means suppose here actually our input string is LMCT. Okay, so they are saying that I can actually add any character. Suppose in this position I actually have added character L. Okay, L. Then how many LCD is present? If I want to count that, how many actually LCD is present in this resulting string? So one string, one L will be this C. Sorry. So one L will be this C and T. So this is one LCT. Another LCT is that one L is from here and C is from here and T is from here. So this is actually another LCT. Got it? So this actually how many actually LCD is present here? Actually 2. Got it? So this is actually one possible answer, because without any extra character, our answer was, or our number of actually LCT present in the input string was actually only once. Correct? This LCT. But after adding one character here, actually I am getting actually 2. So this is actually better. So our current answer will be now 2. Got it? Now, so now actually I can actually explore here actually. So in each position, I can actually see that maximum actually I can actually generate actually 2 LCD string subsequence. So that's actually our answer is 2. Clear? Now how can I count? How actually counting this? So let's see. Suppose we actually have L C T. Okay. Now, so to get LCT, what actually I have to know? So I know that our last character should be T. Okay. So that means first of all I have to know that how many actually LC I have seen. Then the T will be added to the subsequence. Correct? Because this is subsequence. So here actually you can see that. So before counting the LC, how shall I count that? I have to know that how many actually L I have seen. Then actually how many actually C I have seen till now. Got it? Because this is subsequent, that means this is order is matter, right? Here actually, so that means here actually this is actually L. Suppose actually first of all L is 0, LC is 0 and LCT is 0. Okay, because our target is to count the how many LCD is present. Okay, so that's why to count the LCT, we have to know that how many LC I have seen. So if there is suppose actually LC1 LC another LC, suppose our current character is T. So how many subsequence I can generate which actually LCD? T can actually add here and I can actually add here. So our answer will be 2. So that's why it is matter that how many LC I have seen till now. Got it? Now when you're trying to calculate that how many LC I have seen, that time actually order is matter that how many actually L I have seen, then actually I can actually generate, I can actually add C after that. Got it? So that's why actually I need 3 variables. One is counting the how many L I have seen till now. One is LC and another is counting how many LCT I have seen till now. Okay, because our goal is to count the number of LCT. So here actually this is character L. So our L will be increased by 1. Okay, so previously it was 0, now it is 1. Now next character is again L. So is it possible to generate any LC or LCT? Not possible. So I can generate only L. So now the count will be increased to 2. Next is this L. So this is third time. So this will be increased to 3. Now I actually got C. So which actually I can generate by using C? I can generate only LC. So how many LC I can generate? That depends on how many actually L I have seen till now previously. So how many L actually I have seen till now? 3. So that's why LC will be how much? 3. Got it? Why actually C? It is LC is counting as 3. You can just see in the image that this is still 1 L and this is C. So this is 1 LC. Okay, this is another L, and with this C actually I can generate how many? Another LC. Just see another, this L I can generate another LC. Got it? So that's why how much LC actually I can generate, it depends on how much L I have seen till now. Got it? So previously I have seen 3 L, so that's why how much LC I can generate, that will be 3. Got it? Now just go to the next character. Next character is T. Okay, so T, which actually subsequence I want to generate, I want to generate LCT. So that's why I want to know that how many LC I can generate, or I have generated previously. So that actually previously it was 3. So you can see that our LCT will be, I can generate by using the current T, that will be 3 number of subsequent. Just visualize the diagram that our input string was LCT. So I am saying that I can generate 3 number of LCT subsequents, right? So just see that I am taking this L, this C, then this T. So this will be LCT, one LCT. Next is I am taking this L, this C, this T. This is another LCT. Next I am taking this L, this C, this T. This is another LCT. Any other possible till now, till this T? Only 3. This is clear. Why actually I am saying that I can generate LCT, 3 number of actually LCT I can generate, and you can just see that how many LC I can generate, that is also 3, and how many L actually I can generate, that is also 3. So LC is depend on that how many L I have seen, then only I can actually on each subsequence I actually append C, the character C. So that's why it depends on how many L I have seen till now. Then actually it depends on how many LC I can generate from that. Then for LCT, it depends on how many LC I can generate in the left hand side. Then in all the subsequents I will actually append the T. Then actually ultimately our subsequence will be LCT. Clear? The logic is to count the how many LCT is present in the any input string. Clear? So this is clear that it will take actually big of n to calculate, to count number of LCT, correct? Because I have to iterate each character, then I will say that how many L actually I can generate, how many LC I can generate, LCT generate. Then ultimately after completing the iteration on the input string, I can actually whatever actually value actually I will have in the LCT variable, that actually indicate that how many actually LCT subsequent I can generate. Got it? Clear? So to count this will take actually big of n. Now how many actually position actually possible? Big of n plus 1, because there is suppose x, y, z. The input string is x, y, z, 3 character. So how many actually position actually I can actually add? 1 position, second, third, fourth. So this is actually n plus 1. Got it? So n plus number of position actually I can actually explore. And in each position actually how many actually character actually I can actually add? 26 character, because our subspace will be A to Z. Got it? And for each, after adding a new character, I have to count that after each character I have to check that how many actually LC is present. So this will again take n. So you can just see that it roughly take n square. So just see what is the range of n. What is the range? Range is actually 10 to the power 5, the length of the input string 10 to the power 5. So it will actually 10 to the power 10. So 10 to the power 10 actually greater than 10 to the power 8. So it will actually give us a TLE. Clear? Why actually this brute force approach will not work? Now let's see some observation, like how can we optimize this. So I actually what is the brute force time? N plus 1 into 26 into n. So this is number of position, and this is actually the character. Actually I can actually add 26 character in each position, and after each character actually I have to check that in the resulting string how many actually LCD is present. So this will take big of n. Now suppose our string is LCT. Okay, so this is the input string. So only one subsequence I actually have in the initially actually I have only one subsequence of LCD. Now in this position suppose I have added A. So is it possible to increase the number of subsequence which is actually LCT? Not possible, because this character is not contributing in anything in the subsequence LCT, right? So similarly for B, if I add B, so does it matter that it will actually increase the number of subsequence of LCD? It will not increase, because B will not be counted in the subsequence in any way. So our only character, actually I can actually do LCT. Then actually it's possible, it may actually increase the number of subsequences of LCT, correct? So that's why from 26 I can actually decrease this to 3. Got it? That I can only explore that. I will try to add L, then I will check in the resulting string. I will check that how many actually LCD is present. Then again actually I will check C with C. Then I will check with T. Clear? So I optimize here from 26 to 3, but still actually it is actually 3 into n plus 1 into n. Correct? So it is still n square roughly. So somehow actually optimize here from n plus 1 into n. So I know that I can actually add the new character in the n plus 1 position, right? In each position, so I can actually add, and I know that I can only add 3 characters. Then actually it can actually affect our answer L, C, and T, right? But this n actually checking the total number actually LCT is present after in the resulting string. Can I actually optimize this? Yes. How? So our target from 3 into n plus 1 into n plus into n, I want to actually decrease that each time I am actually iterating the whole array, the whole in the resulting array, resulting string. So can I actually optimize this? Try to optimize here, because I can't actually optimize here because I have to explore all the position. But to count the number of LCT in the resulting string, I can actually optimize this. How? Suppose our string is X, Y, Z, all actually capital, okay, X, Y, Z. Now suppose here actually I have inserted a new character between any character from LCT. Suppose I have actually our resulting string is X, L, Y, Z. So that means actually I have taken L. Okay. So if I actually add L in the new string or in the input string, then what actually it actually increase our result. So that means I have already inserted L. So that means I have to see that how many CT actually is present in the right side of this. Like I have added new character it's L, then when actually it is affect our result. If I know that how many actually CT subsequence is present in the right side of the current position, because then actually it will resulting the string, the resulting string will be then subsequence will be LCT. So that's why here when actually inserting L, then actually I have to know that how many in the right side, how many actually CT is present, subsequent CT is present, I can generate. Got it? This is for insert L. So that time I have to know that from right side how many CT I can generate. Before that it is clear that why actually I will only add L, C, and T, these 3 characters. This is clear because this can only affect our answer. If I actually add A, B, C, this will not actually affect our answer because this will not be counted in the subsequence of LCT. So that's why our search space actually decreased to 3, means 3 characters L, C, and T. Now when you are trying to add character L, suppose in the current position, so when actually it actually increase our result. If I know that if actually it create a new string of LCT, so when actually it is possible to generate LCT, so I have to know that how many CT actually I can generate. Then it should be present in the right side of the current position. Like here actually I have CT, and suppose here actually I actually have XY. Okay. Now here actually I am trying to add L. Does it actually affect our answer? No, because LCT will order actually matter here. So there is no CT in the right side. So this will not affect actually our answer. Got it? So that's why I have to know that from the current position, right side of the current position, that how many CT actually I can generate. Then actually in the prepend the actually the L all the subsequents actually that actually CT. Clear? So that's why when I'm trying to insert L, I have to know that in the from the current position on the right side, how many CT actually I can generate. So that means, so I have to know that suffix of CT actually I can generate here. So the current index I. Clear? That means actually new string or new subsequence will be added into our answer. So by default answer is answer, the count of LCT, and the new it will be added there how many actually suffix of CT is present. Suffix means the subsequent CT is present. Got it? From the current index of I. This is clear. Now next case is insert C. So then what it to do? What actually it actually affect our answer? So our answer will be same. It is by default, but new how many new string new subsequence will be generated? That is depend on how many actually prefix of L is present and how many actually suffix of T is present. This is clear. Why actually I am actually multiplying this with the prefix of L and the suffix of T, because the current character is C. Okay. When actually it actually in add actually value in our actually answer. When actually I have some character in the left side of L and in the right side as T, then actually I can actually generate new subsequence of LCT. So that's why I have to know that from the left side how many actually L actually I have, and from the right side I have to know that how many T actually I have. Now suppose actually 2 L actually is present and actually 3 T actually is present. Now here actually I'm trying to add C. Okay, so how many actually actually multiplying this, just see that how many actually LCT actually I can generate. I will take this L, C, this first T. So this is one LCT. So again the actually one L, this is next C, this actually next T. So this is LCT. Next is this L, this C, I have changed the T. This is another LCT. Next is, so this is the L, this is the C, this is the first T. So this is LCT. This is the L, this is the C, this is the second T. This is the L, this is the C, this is the T. LCT. Just see that how many actually LCT I have generated. I can actually generate 6. So there is a 2 into 3, because for each L I actually have all the T, and that's why 2 into 3. So that's a prefix of L, how many actually L actually I have in the left side and how many actually T is present in the right side. Got it? When you are trying to insert C. Now another case will be what? I can actually insert T. So our LCT will be same by default because it will be anyway always be present. Now when you're trying to add T, then when actually I can actually increase our answer. Just see that if actually present actually left side actually I have some LC, then actually if I add T if I add T on the subsequence that is present as LC, so that many times actually I can actually generate new subsequence of LCT. So that's why in the prefix of I have to know that in the left side I have to know that how many actually LC I can generate. Got it? From the left side actually I need to know LC. So this is clear, the 3 case. So that means which actually prefix and suffix we need to know. So insert L. So that time I need to know that from the suffix of CT. Then actually I will actually prepend the C in all the subsequence of CT. Right? When I am trying to insert C, so that time actually how many actually new subsequence actually I can generate of LCT, that will be prefix of L into prefix of T. Sorry, this is not suffix of, right? Because in the right side I need to know that how many T actually is present. So this will be suffix of T. Now insert T. So that time in the prefix on the left side, I have to know that how many actually LC I can generate, because that's why I can actually only add t in the at the end. That time only it will be actually increase. It will actually generate a new subsequence of LCT. So that's why in the prefix I have to know that how many actually LC I can generate. So that's why you just see that what actually I have to generate. Pre-calculate that in each index I have to know that each index I suffix of CT, suffix of T, and each index I have to know that prefix of L, actually prefix of L, and I have to know that prefix of LC. This is clear. I have to pre-calculate that these four values. Got it? So how can you calculate this? Suppose we actually have LC. So just see the example 1. So LMCT. So what I have to calculate? Four value I have to calculate, right? Suppose this I want to calculate prefix of L. You want to calculate prefix of LC. Here actually I want to calculate suffix of T. And here I want to calculate suffix of CT. Okay. So now let's see. So initially all are actually 0. Okay, prefix. So for L, how many actually prefix of actually L actually I can generate? So this will be actually 1 now, because previously it was actually 0. Now actually there is a new character of L, so that's why it will be increased by 1, the L. Now the current character is L, so it will be still same, LC it will still same. Okay, now go to the M. Okay, so can I actually generate a new L subsequence of L? No, so this will be still 1. Can I actually generate subsequence of LC? No, because the current character is M. So this will be still 0. Next, go to C. So will it actually create a new subsequence of L? No. So that's why still it will be 1. Next, can I actually generate a new subsequence of LC by using the current character C? Yes. How? So I have to know that how many L actually I can generate. Actually, I can actually append the C into all those subsequence of L. So how many actually L actually I can generate previously? So current index is this, and previously I can generate only 1 L, subsequence of 1 L. So that's why it will create how many LC? Only 1 LC I can generate. Clear? Clear? Why LC can generate only 1? Because previously I can generate only 1 subsequence of L, and those many times actually I can actually append the C into all the subsequence of L. So only 1 subsequence, so that's why only 1. Got it? Next is character is T. So can I actually generate a subsequence of L? No. Using the current T? No. So it will be still 1. Next, can I generate any subsequence of LC by using the current character T? No. So this will be still 1. Okay. Now go to the next thing. What is the suffix of T and suffix of CT? So that means I have to iterate now from right to left. So this is actually T. So it is actually initially 0. Now this T, so it will be something T. So can I actually create a new suffix subsequence of T by using the current character T? Yes, because this is T, so it will be increased by 1. So previously it was 0, and 0 plus 1 it will be 1. Next, can I actually create any subsequence of CT by using the current character T? No, not possible. So it will be still 0. Next, character is C. Can I actually create a subsequence of T by using correct character C? Not possible, so it will be still 1. Can I create a subsequence of CT by using the current character C? Yes, it's possible. So before that, to generate CT, I have to know that how many T subsequence of T is present. So how many subsequences T is present? Only 1. So that's why it will be actually 1. Clear? Why actually CT, the number of subsequence of CT is 1? Clear? Because in the right side, how many subsequence of T is present? Only 1. So that's why CT actually, I can actually prepend this into only one subsequence. So that's why this is actually 1. Next character is M. So can I actually create a new subsequence of T by using the current character M? Not possible, so it will be still 1. Next, can I create a new subsequence of CT by using the current character M? Not possible, so it will be still 1. Next character is L. Can I actually create a new subsequence of T by using the current character L? Not possible, so it will be still 1. Next, by using the current character L, can I actually create a new subsequence of CT? Not possible. So this will be still 1. So this is the thing I have already calculated and stored in the 4 different vectors. Now what I want to do? So first is our target is to insert a new character in this position here. Correct? So first of all, try to insert L. Right? So for L, what is the case? Case is that count that how many suffix of CT. So okay, before that I want to know that in the input string without any adding new character, how many actually LCD is present. So for that, how many actually count LCD is present? Only 1. Okay, because this will be anyway present in all the situation, and I have to check that how many extra new subsequence I can generate, right? So that's why the first case is insert L. So I have to count that how many actually I have to know the suffix of CT. So for this index, suffix of CT, it was actually 1. So by default the answer is 1, and how many suffix I can generate? The suffix of CT is present 1. So this will actually 2. Okay. Now try to insert C. So if I want to insert C, suppose, then what if I have to know that how many prefix of L into suffix of T. So for this position, what is the prefix of L? That is 0, right? So 0 into 1 plus 0 into, this is for L, this is for C, 1 plus 0 into suffix of T. Suffix of T means 1, 0 into 1. So it is actually ultimately 1. So if I actually insert any character C here, so the contribution or effect will be 0, ultimately 0, because 1 plus 0. Got it? Now try to insert T. So if I insert T, so what is actually I have to know? I have to know the prefix of LC. So prefix of LC for this particular index 0, it is to 0. So again, the how many characters I can new LCD actually I can generate? That will be 1 plus 0. It will be again 1. Got it? So out of this, the maximum value actually I got 2. So in this position, actually I can generate for each position. So you can just see that for each position. So this is for 0th position. This is for first position. This means I want to insert a character here between L and M. Then I will actually add any character between M and C. Then actually it will actually counted. Got it? This is clear. So here actually ith index indicates that from 0 to I minus 1, how many L or LC present. So just see that from 0th index, it indicates 0. That means 0 to 0 minus 1, because there is no more character in the left side of the current character of index 0. So that's why it indicates 0. Similarly for LC also, the 0th index indicates 0. That means there is no more character in the left side of this till 0 minus 1, you can say actually. So now for the index 0, I am indicating the first index. I am counting in the storing in the first index, index number 1. So So what actually I'm storing? I'm storing that from 0 to I minus 1, how many actually L actually is present. Similarly for 0 to I minus 1, here actually first index, how many LC is present. Got it? I can actually generate. So in this actually it is clear how can I use the prefix and suffix vector to actually easily pre-compute or easily calculate that how many new LCT I can generate. Clear? So from brute force approach, you just see that previously it was actually n plus 1 number of position. It was actually 3 characters actually I can actually add, and to compute that how many actually LCD is present, it was taking actually big of n because I have to iterate the whole array. From that, it will take a constant time. N plus 1, it is okay that I have to explore all the position. It's okay to check all the characters, possible character, 3 characters L, C and T, and it will take big of 1 constant time, because I have already calculated that how many actually, what is the prefix of L, what is the prefix of LC, what is the suffix of T, what is the suffix of CT. Got it? So it will take a constant time. So it is actually easily pass, right? So now what is the code? If you have any doubt, any suggestion, you can comment on that. And if you are not subscribed, please subscribe channel if you found this video useful. Now go to the code. So first of all, by default, I have to know that without adding a new character, what is actually LCD, how many actually LCD is present. So that's why I have to need 3 variables, one for how many L is present, how many LC is present, how many LCD is present. I have already explained why actually I need 3 variables, because our ultimate goal is to count LCD. So before that, I have to know that how many LC is present in the left side. Then actually I will actually append the current character T. And for LC, to generate LC, I have to know that how many L is present in the left side of that current character C. So that's why I need 3 variables. Okay, so now iterate the input string S. So if the current character is L, increase the count of L. So L plus plus. If the current character is C, then what actually I have to do? I can actually check that how many LC actually I can generate, because the current character is C. So that's why it depends on the how many L actually I have seen in the left side. So that's why LC will be increased by how many L is present till now. But if the current character is T, then I have to check that how many LCT I can generate. So that depends on how many LC I can generate. So that's why LCT will be increased by plus of LC. It indicates how many LC I have seen till now in the left side of it. So after this for loop, in the LCT variable, I can easily say that how many actually LCT is present in the input string. Now what I have to do, I have to pre-calculate the prefix of L and prefix of LC and the suffix of T and CT. So that's why you can just see that I have taken 2 vector, that is calculate the prefix of L, size of n plus 1, prefix of LC, size of n plus 1, and the initialized is 0. Now iterate the each character. Okay, so that's why I am iterating from 0 to n minus 1, and for the current index I plus 1, it will be initially it will be same as the left side. So that's why L of prefix of I plus 1, it will be L of prefix of I. Similarly for LC of prefix of LC is also same as I of I plus 1, it will be same as index of I. Now it will change if the current character is L. So if the current character is L, so what actually it will affect only the prefix of L, because it will create a new subsequence of L. So that's why it will increase the subsequence of L of prefix of I plus 1 by 1 prefix of L. And then what actually I am storing at the I plus 1, because I have already explained that from 0 to I am storing the value in the I plus 1 index. Got it? Now for if the current character is C, then it will create a new it can actually create a new prefix of LC. So it depends on the how many actually L actually I have seen in the left side. That many times actually the LC actually I can generate. So that's why if it is current character is C, so I am actually adding new, how many actually new LC actually I can generate. That depends on the how many L prefix of L in the index I, not I plus 1. It is storing in the I. Okay, means the left side. That many times actually LC I can generate. Got it? So after this for loop, in the these 2 vectors, I can actually easily say that I can easily fetch the value that how many actually L in any index I, how many L actually I can generate, how many LC I can generate, right? Similarly for I have to calculate the suffix of T and CT. So again I have taken two vector of same size n plus 1, and I'm iterating from right to left because this is to calculate the suffix. So I'll check. Similarly, it will be same. The value of T and CT, it will be same as the right side of the index. If the current character is C, then it will create a new subsequence of T. So it will increase the count of I, not I plus 1. Got it? Else, if the current character is C, then it can actually create a new subsequence of CT. So that depends on how many T actually I have seen the right side. So that's why if the current character is C, so I will see that in the suffix of T, in the index of I plus 1, means the right side of this current index I, that how many actually T actually I have seen in the right side. That many times actually CT I actually prepend that in all the subsequence of T. So that's why I will increase the count of CT by number of suffix of T I have seen the right side. But now what I have to know, I have to maximize the number of LCD in the input string or in the resulting string. So I have to explore all the position. So the position will be from 0 to n, because at the end also I can actually insert, and at the front also I can actually insert. So that's why the search space will be from 0 to n, not 0 to n minus 1. Now our initial answer will be LCD. In the input string, how many LCD is present? I have already calculated here in this for loop, right? So our initial answer will be same this. Now for each position, our target is to add L, either C or either T. So if I actually add L, insert L, then what will be this? When actually it will actually create new subsequence, I have to check that how many actually CT is present in the right side of that current index. So that's why, and the LCT will be same because it will be anyway present, because this is input string. In the input string, those many actually it will be present after, without, and with adding any new character. So that will be present, and I have to check that how many suffix of CT is present in the current index I. Got it? This will be added. This actually initially it is present LCT, and this many number of actually new LCT will be created if I actually add a L here actually in the current index I. But now I will take the maximum out of these two, and similarly I will explore that if I actually add C here in the current index I, then I will check that how many LCT will be new LCT will be created. That is how many actually L actually present in the left side, how many actually T is present right side, and multiply that. So that's why LCT plus the prefix of L of index I and the suffix of T of index I. Okay, I have already explained the logic, and similarly for if I actually add T here, so that's why I have to know that time that how many actually LC is present in the left side, prefix of LC. So that many times actually T actually I actually add all the subsequence of will be generated in new LCT. So I'll add this of LC of prefix of I, index I, and out of this I'll actually take the maximum value. Ultimately, after checking all the position, I actually have the maximum answer I can actually have, and ultimately return that answer. Got it? I have shared this code in the description. You can check that. Bye. And you have any suggestion, you can comment on that. And if you found this video useful, please like the video. Thank you.